Hello there, Mr. Sutton here, bringing you the Algebra 2 3-1 Part 2 homework solutions on solving quadratic equations by factoring. And in this one we're dealing mostly with cases where a equals 1, so the easier cases. For this problem, we see that we're already zeroed out, so all we have to do to solve by factoring is factor the left side here and set everything equal to 0. So I'm looking for numbers that multiply to 8 and add up to 6. 1 and 8 doesn't work, but 2 and 4 does, positive 2 and positive 4. So I can split this up into x plus 2 and x plus 4 equals 0. And then just zeroing each of these out, we see that x equals negative 2 for this first parentheses and negative 4 for the second. To solve this equation by factoring, I first need to zero out the equation to use the zero product property. So I'm going to subtract 45 from both sides to get that 0 on the other side. And now, since I've got just a value of 1 here, we're just going to figure out numbers that multiply to negative 45 and add up to negative 4. So 1 and 45 doesn't work, 3 and 15 doesn't work, then we've got 5 and 9. Positive 5 and negative 9 adds up to negative 4. So we have x plus 5 and x minus 9. And then setting each of these equal to 0 to solve it, we have x equals negative 5 for that first parentheses, and 9 minus 9 is also 0, so that's another answer. To solve this equation, I'm going to resist the temptation to divide by u, because dividing by a variable, I might be dividing by 0. Instead, I'm going to add the 9u over to the left side. When in doubt, zero it out. And I'm going to use some factoring. So if I take a u out of here, that leaves me with u plus 9, and then setting each of these factors equal to 0, we have u equals 0, literally, for this u out here. And then if u plus 9 equals 0, that means u could also be negative 9. To solve this problem by factoring, I notice that I've got an a squared minus b squared sort of situation here, a difference of squares. So I can factor this by just square rooting these two terms and then putting them in a plus and a minus parentheses with each other. So we have the square root of a squared, which is a. Square root of 49 is 7. So that leaves us with a plus 7 and a minus 7. And then setting each of these equal to 0 and solving, we have a equals negative 7 for the first one and positive 7 for the second one. To find the 0 of this function, I'm going to start by actually setting this function equal to 0. So that's a quick first step. And now I just have to factor the left side here, or solve it through some other means, but factoring will work. So a couple ways to do this. I could ask for things that multiply to 121 and add up to 22. Another thing I could try, since this is a perfect square kind of sandwich here, is I could square root the x squared and the 121, and then see if I put those in a squared parentheses, an a plus b squared sort of thing, if that would give me this 22. So square root of x squared is x. Square root of 121 is 11. The middle term is positive, so this might be x plus 11 squared equals 0. But let me just double check. If I multiply the x and the 11 together and double it, that 2ab part of it, do I get 22? It turns out I do. So this is actually the correct factorization. Setting this equal to 0 now, we have just x equals negative 11, and that's just a double root, but we only have to write it once.